So there is, okay, so for you, what we need to do is combustion and the addition reaction with bromine and hydrogen. There's hydration, addition of water that you don't have to do. Okay, so alkenes undergo combustion as well. Combustion means you take the alkene, then expose it to oxygen. After the oxygen exposure, the carbon dioxide and water will form. But if you compare this reaction with the combustion reaction with alkenes will produce more soot than alkene because they have higher percentage carbon. Okay, so okay, if you want to differentiate alkenes and alkenes, but you cannot use bromine water, the worst case scenario, you can just burn the two of them and see how much smoke they produce. But it is not very scientific because the naked eye cannot differentiate how much soot you can get. But it's like worst case scenario. Okay, come, write the word equation and chemical equation for the combustion of ethene. Ethene plus oxygen, carbon dioxide, and water. Okay, balance it. C2H4 plus, not balanced. Let's see. So two carb. Okay, I write another one. I copy yours. Okay, so what is this number here? 3. Okay, so you have two carbons here. Then, okay, this one correct. Then, yep. This is the reaction that differentiates itself from alkenes. Alkenes undergo a reaction called the substitution reaction. So alkenes undergo another type of reaction called addition reaction. So alkenes have this double bond here. So this double bond, what happens is it can break up. Once it breaks up, carbon has 4 bonds. It has a free bond out here and it has a free bond out here. So what happens is it can react with another substance here like this XY. So this X can be added to that first carbon and the Y can be added to the second carbon. Then eventually you get this. The addition reaction changes the unsaturated compound to a saturated compound. Okay, so we go back to this. So the first reaction is the addition of hydrogen. The addition of hydrogen sometimes is called hydrogenation. There's a condition, 200 degrees Celsius, nickel catalyst. So what happens is the alkene, when the added hydrogen, will become alkene. So this breaks into 2. This double bond can be broken and then it opens. One hydrogen goes to here, the other hydrogen goes to here, like that. So the end product is like this. So you convert unsaturated hydrocarbon to a saturated hydrocarbon. Okay, then there's this definition, a polyunsaturated compound. So back to here, unsaturated compounds contain a double bond. Then a polyunsaturated compound has more than one carbon-carbon double bond. So you would use hydrogenation to convert your unsaturated compound to saturated compound. Then it converts vegetable oil to margarine. These two are the processes that involves hydrogenation. Okay. So the second reaction is the bromination, or you add bromine to alkene. So this is the basis of the test for alkanes and alkenes just now. So what you do is you pass the gaseous ethene into the bromine liquid. Okay, so what happened is the ethene will decolorize the bromine solution and it becomes colorless. Then the chemistry behind it is like this. You have ethene and then you have bromine here. This splits and this will split. Because it splits, these two bonds become free. So bromine can go to the first carbon and bromine can go to the second carbon. So you get this product called 1,2-dibromoethane. Okay. So what is the term to describe addition of bromine to alkenes? Bromination, yes. Okay, so you look at this. So what happened is you have 2 added to it, right? 2 bromines added to it. So now the substance is dibromoethene. So it can be, you have XY. XYs are the position of the bromine molecules, right? Atoms, right? So that means, okay, back to this. This 1, 2 means it's carbon 1, carbon 2. So the bromine is attached to carbon 1, attached to carbon 2. So that's why it's 1,2-dibromoethane. So this one XY, and it's because it's alkenes, right? So it's likely to be dibromo alkene, 1,2-dibromo alkene. But they say alkene. Because why become alkane, huh?
Yeah.
Why become alkane is like this. You go back to our equation here. Alkenes means it's a unsaturated compound that has a double bond. So once the product is formed, here, right, there is no double bond. So this is a alkane. Okay, so it converts from a alkene to alkane.
It becomes a single bond.
Yeah, then become alkane.
Oh.
You have test tube 1, test tube 2. One is alkane solution, one is alkene solution. So the test tube 1 is still brown. So it remains brown. This one you write remains brown. Okay, this is something that they likely will not test as an exam question, so I'm going to give you the answer. So why is bromination important in the study of alkenes and alkenes? It's important because you need to use it to differentiate between alkenes and alkanes, or differentiate it from saturated from unsaturated, or vice versa. Okay, complete the following chemical reaction if there is a reaction. So there is no catalyst down here. There's no UV light. It's just dissolution and bromine water. No reaction. Why is there no reaction? C2H6, that means this is one, you must recognize that it is a alkane.
It's an alkane.
So an alkane without a catalyst, that means without UV light, will not react with bromine. So that's why there's no reaction.
It means for alkane it will be C2. C2 is a single bond. And for alkene, it's C4.
That is, alkanes, the general formula is this. Then alkenes, it's CnH2n. Once you see that the number, right, don't fit CnH2n, that means this one is definitely not alkene. So if it's not an alkene, then you have to recognize who it is. So then you recognize that it is an alkane. Once you recognize it's an alkane, and then at the back of your head, you know that alkanes don't react with bromine unless there's a light. So here, there's no mention of light. That means this alkane cannot react with bromine. Then alkene, the structure is like this. Okay, so if it's alkene, then it's C2H4. So which is the next one? This one. C2H4. So what is the product?
Is that in bromination for alkenes?
Yes.
It's not losing any hydrogen.
It won't lose any hydrogen.
It
That's
will
true.
just gain bromine.
Yes. So it becomes C2H4Br2. If you draw it, if they ask for the structures, whoop, like this, you got H, 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 H plus bromine. 2 is like this. Then it becomes C, C, H, 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 H. Okay. So one bromine goes to one carbon. So bromine here, bromine here. So this is the structural formula for the product. Just for interest sake, there is this addition of water to alkenes. So what you get is you add water, then conditions you don't have to know because you just need to have an impression. You know such thing exists. So there's this water molecule here. Water molecule will split like this. So eventually one hydrogen goes to here, one water, the OH goes to the other one. So it is exactly the same as how bromine is added and how hydrogen is added to 18. So when you have this process, right, you will convert alkenes to alcohol. This is what happens. So then we will hear the addition polymerization. Addition polymerization happens to alkenes. So box down here, right, what this means is you have a ethene here, and you have N means a large number of ethene molecules. So you put them together via the addition polymerization process, then the double bond gets opened up, and then it becomes a long chain molecule with a lot of ethene molecules joined together. So if I explain it, it will be like this. So you have one ethene and then the other ethene molecule. So you put them together. Okay, maybe say this one, I draw another one. Okay, so we have 3 ethene molecules. So through the polymerization process, this thing opens up. So once this opens up, then it becomes a single bond, and then 2 spare bonds appear. So the other carbon, it can open the double bond as well. So this one has a spare bond also. So this carbon will bond with the other carbon from the other ethene molecule. So the third one, same case, it repeats itself. So this is the outcome. So no atoms are lost in the addition polymerization process. That means they just join and then that's it. because there is another polymerization process where atoms are eliminated, but that is not in your syllabus.
Okay.
So these are all examples. So you have polyethene. Polyethene, the monomer is this, and then if it forms a polymer, then it becomes like that. So the use is plastic bag, sheet, and plastic sheets and all. So these examples, right, are just for information sake. The only ones that turn up in the exam probably is polyethene. Then polypropylene, the monomer, then like that. So those are the uses. So you can just look through them. This is the styrofoam, your food packages and all that. This is styrofoam.
Okay.
Then this is Teflon on your frying pan. Then this don't care. Perspex is found in your lab, your test tube. Okay, so come to terminologies, right? So the molecules down there, the ones we start with just now, the ethene molecules, right? Those are called monomers. So after the process, the polymerization process, the final thing that you get is called polymer. Then there's this N down there is infinite number, large number of molecules. So this I told you already. This I taught you just now. So this is the steps. Okay, so look at this, right? There is something that they will ask called the repeated unit. The repeated unit, that means is the one that is repeating.
Yeah.
So the repeated unit, if they ask you to draw it, right, you are supposed to draw it without the double bond.
Okay.
Yeah. So they have three things. They either ask for monomer, they ask for the polymer, or they ask for the repeated unit. So if they draw monomer, that means you have to draw this one with the double bond.
Okay, sure.
Okay, so this is the structural formula, this thing. Then this is a reverse question. So what happens is they give you the polymer, then you are supposed to find the monomer. The reverse process. So you'll go to the polymer, look for the repeated unit, that means this. So once you get the repeated unit, you want the monomer, that means you just draw it with the double bond.
Yeah.
Okay, so from here onwards is yours. So we have this process of addition polymerization. Then you are supposed to name the monomer.
Is it ethane?
Is this one, right?
Yeah.
So it's a double bond, that means it's an alkene. Then alkene, that means the name ends with ene. Then 2 carbon, that means in front like that.
So it's an ethene.
Yes. If it's an ethane, there will be no double bond.
Okay.
Then you have explained why this type of polymerization is an addition polymerization. So it's because your monomers that you start with, right, are unsaturated. So then the process joins the monomers together to form a long chain single product. So then it becomes a polymer. So then the whole process is a polymerization. Then you can also add that no molecules and atoms are lost. So it's an addition polymerization process.
But since no molecules are lost.
No atoms are lost. Because they ask for addition polymerization. So if there is if you didn't mention that no molecules are lost, then it could end up as a condensation polymerization process. Yeah. Depends on how many points they give you.
Okay, yeah.
Okay, name the polymer form.
It's a double bond. Polyethene.
Yeah. You can write with the bracket or without the bracket. Draw the structural formula showing one repeated unit to represent this polymer. So one repeated unit is here. Then they say represent the polymer. Wow, never. So these are the things to watch, the terms, the terminologies, and the commonly asked question. Ask for that 3. Polymer structure formula, then monomer repeating unit. Then state 2 functions of this polymer. This is polyethylene. You can go and look at the list, the example before this. So what could this be? Polyethylene function.
The plastic bag.
Plastic bag lah, container lah, thin film lah. Everything you can find in the kitchen. This one is a little special. You can think about it, then I will tell you what to do. Or you can suggest a method, then we discuss about it. What do you think?
I'm not sure.
Do you know how to find relative molecular mass?
Use
So let's say I have Na2CO3. How to find the relative molecular mass?
must use the system.
So we must go to the periodic table,
Yeah,
look for the atomic mass.
Yeah.
So look for the atomic mass, and then this 23, this is 12, and then this is oxygen is 16. Then do this, then plus 12 plus 16 times 3, right? Something like that, right?
Yeah. Something.
Okay, so now they say one part of the polyethylene is formed by 10,000 units. Each of this is a C2H4. So then they tell you that there are 10,000 units. That means 10,000 of this C2H4. So what you do is you find the relative molecular mass of one unit. So C2H4 is 12 times 2 plus 4 times 1, right?
Yeah.
So like this. So how to find the relative molecular mass of this part of the polyethylene?
Is it 26 times the amount?
So 26 times the 10,000.
Yeah.
26 or 28? 28, yeah. 12 times 2,
Yeah,
24.
28. 24
Plus 4,
4.
28. Okay, so this is 28 and 28.
Okay.
Okay, so now then we throw the monomer at you, and then you are supposed to find the polymer.
Yeah.
So let me give you an example, because this monomer looks significantly different from ethene.
Yeah.
So if you notice, just now ethene, right, polyethylene, what we do is we take a few of this polyethylene in this arrangement, then we add up, right?
Yeah.
So then you will have 1, 2, 3, 4 groups of atom around the carbon like this.
Yes.
Yeah. So and any monomer that comes along, we need to convert the appearance to this ABXY pattern.
Okay.
So that means like this around the one with the double bond, so like this, and then this is one, and then this is the other one. So this becomes CH3, CH3. So the polymer, right, will be, if I want to draw a few repeated units, so I'll just draw 2, then like that, then we have the end. So then polymer means we have to open the double bond. So I open the double bond, it becomes like this, and then this side it opens 2, so like that. So this polymer will look like that.
Yeah.
I draw 2 units, the answer key draw 1 unit. But it's the same thing. So then come to here, you are supposed to determine the monomer. This is easier, right?
So must change it back
to the one with the double bond.
So the double bond is in the middle, right?
So first you circle the repeated unit. So the repeated unit is this.
Yeah.
So then you will draw the repeated unit CnHCH3. This line, right? This line is joined to the carbon.
Okay.
So you don't write this. Yeah, don't write this. Don't write like that, you'll get it wrong. So then I return the double bond to it like that. This one is wrong. You saw the difference between these two?
Yeah.
The second one, right? The carbon is connected to the H and N. So that one is wrong.
Okay.
Next one. We'll let you try first.
Repeated
So first we must change it to the ABXY format.
Yeah. So CH.
So it's this 1, 2, 3, 4.
Yeah. So it's just there's 2, then the other C is connected to the Cl and the CH3, right?
Like that.
Yeah.
Same. Then you can have another one. Then you take out this. Then if the question says that draw the polymer with 2 repeated units, then you can just draw like that and don't put this. With 2 repeated units, they specify the number of units. If not, then
Okay.
it's yours.
So I use the repeated again to
Look for the repeated.
which is the BRC2. Yeah.
Then you draw it, copy out the BRC2 thing. C3H7H, then return the double bond.
Yeah. Okay. Can that 2, like the 2 to find the thing, right? Can it be like not in like the first 2? Can it be like the second 2, or will it always be the first?
You always look for the repeated unit.
So it can be in any position.
Yeah, you can use this because this repeated unit and this repeated unit is the same.
Yeah, but what if like actually wouldn't make
it won't make a difference if it's repeating. Like that also.
Yeah. Okay.
Same.
Same, just different positioning.
Yes.